So this is the worst slide in here, and as a neurodiverse researcher, it's like I hate it, but I just want to say that this project and the work we do is a collaboration with a lot of other people, and so I'm going to say we, and it's a big set of organizations. Oh, come on, you're supposed to. So first, I want to tell you why we care about neurodiverse learners and how this came about in our game-based research. And we believe that neurodiverse learners bring not only their challenges to the school environment, but they also bring a lot of cognitive strengths and differences. And we're not the only ones that believe this. Programs in Microsoft and SAP and EY, which used to be Ernst Young, have major initiatives to hire neurodiverse learners into STEM jobs because of the talents. And the words, I'm studying this right now, and the words they use is, it's a competitive advantage. We want their talent. It's not about altruism. They're seeing this as the power of the STEM workforce. So when we look into that, what we look at the research, we see like learners with autism are often associated with what's called cognitive inflexibility, a sort of rigidity of thinking. But if you think of that with a different lens, it can be thought of as systematizing. Sir Simon Baron-Cohen writes a lot about this, a systematizing brain that breaks things up breaks problems up into smaller problems and looks at patterns between them and develops systems to solve problems, and with very high attention to detail. Both those bear out in the research. Learners with ADHD who may be considered having a lack of focus, it's also associated with creativity and innovation and idea generation. I'm going to back up and say this is an overgeneralization, and obviously this is some learners and some people with these conditions, but this is what research has borne out in studies. Similarly, learners with dyslexia, who have difficulty mapping sounds and text to meaning, have also been shown to be quite strong at parsing out detail, like details in blurry or low resolution images. They can actually parse out features better than neurotypical learners. And so all this research is showing neurodiverse learners and people's brains as this mixed bundle of strengths and weaknesses. And so we look in our research at the executive function challenges that many learners, and many more learners these days under the stress and conditions of COVID, bring to the learning situation, such as issues around attention, working memory, metacognition, inhibitory control. And I can explain any of these terms when I'm going to go through fast and then ask if people have questions. But these things can also be seen as persistence and passion for a specialized area, autonomy of thought, where they can come up with novel ideas and not conform to the masses. Think about Greta Thunberg or Elon Musk. And creative problem solving. So this double-edged look of neurodiversity really has gotten us thinking. And this has all come from our research in Zumbinis, which, are any of you not familiar with Zumbinis? Should I describe it at all? It's a learning game that came out in the 1990s from TERC, from our organization. I was not on the original design team, so I can brag and say I think it's, and many people have said it's the best learning game out there, and that it is both a very, very engaging game, as evidenced by its millions of copies sold and long-lasting popularity. And also, we have done research over the last 6 years and have actually shown evidence of computational thinking practices by using data mining techniques to look at the behaviors and patterns learners have in the games and how they solve some of the puzzles, and then do lots of coding and inter-rater reliability and analysis to show that they map to things like problem decomposition and pattern recognition and abstraction. So we've been thinking about computational thinking, which I'm sure is familiar to most of you as CSTA educators. But by that we mean chunking the tasks into smaller manageable pieces, seeing these commonalities amongst tasks, generalizing patterns of tasks and solutions into groups and types, and then creating modifiable and reusable solutions. And when we look, this is the crux, and then I'm going to stop so you can ask questions. But when we look at these, when we've been talking about and working with these constructs with teachers, we've seen two different things. One is some teachers are coming up to us and going, wow, when I do CT with my kids, these kids who have totally unperformed in other areas are like the rock stars, and they're jumping right to solutions, and other kids see them as the ones, the go-to people. And so it's changing their own relationship with other kids and their own self-identity and all that. And we also had special ed teachers in elementary school, particularly, come up and say, these are exactly the skills that I'm trying to teach my kids, but I never had these kind of words for them before, breaking down problems into smaller chunks, so to aid in working memory and attention. And the abstraction part was hard for all the teachers we worked with. It didn't care whether they had neurotypical or neurodiverse, or what, for the teachers themselves. The abstraction part is very hard. So some of the teachers were saying, wow, these scaffolds that you're putting in place for the neurodiverse kids, these are really helping me and all our learners see this. And the systematization that comes with algorithm design was also a real strength for some of the reasons why these kids came. So all that's the background of what brought us to the project INFACT. And at this point, I just want to stop because I know I've gone through a whole short amount of time, and just ask if there's any questions about any of this, or if you want me to go back and unpack any of it. So we, based on all this work, got a grant in 2019 from the US Department of Education to work with all those partners that I showed on the first slide to develop INFACT. And what we've built is a portal that teachers can log into just using Google Easy Sign In, and you can create customized lessons of CT activities. These are for grades 3 through 8. I'll explain that in a minute. And all the lessons are based on the computational thinking practices. There's different topical sequences that we go through. I'm pointing at my screen as if you can all see. The sequence is not mandatory or rigid, but it's how the activities build upon one another. Within those sequences, each activity and the sequence itself has activation activities to sort of kick off and create a hook and introduce the ideas. Foundational activities, which are building the conceptual knowledge about CT. And then applied activities in a variety of contexts, and then a wrap up and assessments. And the contexts that we apply to are games, robotics, coding, and hands-on activities. They're not exactly divided by foundational applied. Foundational applied have both a mixture of those, but we have all those. And so that differentiation portal allows a teacher to go in and just pick all robotics if they want, or all games, or by whatever grade level they can differentiate by, and you can pick, or they can mix them up and differentiate that way. In addition, within the activities, the interactives and the offline activities, there's specific supports for attention, working memory, and metacognition, which I'll show you. And the game, the Zumbini puzzles with the supports are available anytime for kids to go play. So this is a screenshot from the portal when somebody's gone in, they've chosen an activation activity out of a list, and they've chosen a foundational activity, and they would click on this PDF and it would go off into the teacher guide. And they might also click on this other one that gives them off to a digital set of digital cards in Google Slides. And the applied would have stuff in the wrap up. And in the wrap up, there's these assessments we've built that are just bite-sized logic puzzles that use the same concepts in an entirely new context. And they're scored, and the score is given back to the teacher. So that we are still doing research to see how valid those assessments are, but we've worked on them and they're very easy to use. So the types of scaffolds that we put in, this is the Zumbinis puzzle, and one of the puzzle, this is called Allergic Cliffs, and this puzzle wants you to figure out which Zumbinis can make it across which bridge, and the allergic is cliff is allergic to one feature on one value of one feature on the Zumbinis. So it might not like the spring feet, or it might not like the green nose. So you have to try to figure it, and that changes every time you play this puzzle, and for every kid it's different. So it's the process of solving this, it's not the solution. So when we were playing this with neurodiverse learners, they said, I know exactly how to solve it, but I keep on losing track of how many I have of which one. So they wanted a button to say, okay, I want to just look at the ones with sleepy eyes, and we made all those sleepy eyes glow. Just so it doesn't help them, doesn't give them any more information. It just helps them keep track of things. Similarly, in a puzzle called Pizza Pass, where you have to figure out what's the exact combinations of pizza toppings and sundae toppings for each to make each troll happy. So this is obvious. These are all conditionals and repeat loops and all the things that we talked about before as the implicit thinking. But here, learners said, I know how to systematize. I know how to try one at a time, but I keep on forgetting which ones they like, and they weren't inferring it enough from the clues in the game. So we gave them a graphical organizer. This is their own information. We don't give them any information. We just give them a way to keep track of their own information when they solve the puzzle. And then we have something called the expression tool, because kids would be able to solve the puzzle and move on, but we never knew, and they couldn't even necessarily articulate what the rule was that they did and how they thought of that and the conditional logic that they were using. So we put what we call the expression tool at the end. When they finish a puzzle, it pops up and it says, if springs, then it goes over the top bridge, else it goes over the bottom bridge. No, we kept things very intentionally, very graphic, minimal text. We really steer away from things that could be barriers like reading and other things for kids that may keep them from showing their prowess in computational thinking. So this is a offline activity, or this is what, if you hit one of those PDF links, this is the type of thing you would get. And so there's an activity sheet with clear instructions for the teacher, things like a set of I can statements that they can put up for the kids of what the clear learning goals are for each teacher, for the activity, no matter which version. There's multiple entries into these activities often. So some kids might be working on one and part of it, and some on, not part of it, but in one way, and others. Things like these a checklist of the tasks for the activity, just to have kids help for their metacognition and their planning and organizing skills. And on the right, we have the supplemental materials, as I said, are very graphical, and we try to make things so that kids don't rely heavily on the text for all their manipulations, that they can figure things out. So this would be a little graphical thing they did online and write as a repeat loop to set a set of graphical commands in a repeat loop for a dance activity. And this is another example when we do the coding in Scratch, and our researchers are now moving to nets blocks as well. We have multiple entry points, always the same activity, but some kids might get a simple starting with much of it already set up for them. Some kids might get it, the pieces are set up, but they have to put them together. And some kids might get a version of it that's set up, but there's a mistake and they have to find the mistake in it. And these are all the choices of the teacher, that they can choose some for one group, some for another group, even within the same class. And it all looks like they're working on the same activity. So there's no stigma or any kind of pointing out for that. That's a summary of the project. Again, any questions?
I have a question on the sequence, I think, of topics. A lot of times I see repeats early on in the sequence, and in this one it had repeats after conditionals, and I wondered if you had any information about why that sequence is.
That's interesting. It kind of naturally flowed out from what we were doing. The clear commands is very much a it starts out with activities like instruct the teacher to touch their nose, and left right matters, and just being able to articulate or tell your partner how to go through a maze, and just the necessity of clear commands. And then conditional logic and repeat loops, I can't tell you the origin of why we put it in that order, whether it was because we looked at enough stuff that did that not order that we felt it was, or it just fell out that way to us. We're working with people, I don't know, Shushi Grover and Maya Israel and David Weintraub are all members of our team. And so we sit together and think together what the sequences should be, and this is the ones that fell out from our activities. So for transparency, we have published up through repeat loops, and we're still working on variables and functions, and we'll have those in the next few months. And at one point, I do remember at one point, conditional logic and repeat loops were called, we did simple algorithms, and then variables and functions we were calling like reusable or complex algorithm. We had chunked it that way at first, and then I think we thought, okay, too much, and so we pulled those apart. Our curriculum, our activities went through a very, I call it scathing, a review from 5 very candid master CT teachers last spring. And they were great because they just took a lot of time and energy and really ripped through the stuff. Most of the stuff they came up with were things that we had in there, but we hadn't highlighted, like those I can statements and the multiple entry points. We were playing with those ideas and we had them, but they were like, no, you got to throw this right in my face as the teacher and just give it to me easy. Give me that checklist. Don't bury it somewhere. Show me that there's going to be a checklist every time, So it was that kind of thing that they really helped us punch those things out. Kelly, you ready to?
Yeah.
Go?
So my place here is collecting teachers and students to work with us for our efficacy study, which is where we are now. As Jody described, we have a wealth of resources, activities, online, offline, groups, individuals, like we have so much stuff. And we are working with our partners at Knology to run the efficacy study. There's a group going this fall, and we're looking again to start in the spring. And as a good scientist, you all know we are looking for a control group and a treatment group. So our control group would be doing pre and post logic puzzles with their students, with 10 hours of computational thinking instruction in between their regular curriculum work they were going to do anyway. Our treatment group, Jody, if you click, we'll be doing the same pre and post logic puzzles, but using all these INFACT materials. There's a little bit more work involved, some virtual check-ins with our researchers, but the gist of it is pre and post logic puzzles for the students, and
which is one day, right? One class period?
Maybe 1.5 in the beginning and 1 class period at the end. And then using our great materials. Now, that being said, control teachers get access to all the INFACT materials at the end of the study. So you still have that as a bonus. It's not going away. And I know that Jody would support this as well, as long as the portal is is functioning and working, even if our study is no longer funded. Teachers will have access to those materials. And we're gathering up folks to work with us. You guys know how hard it's been out there because of COVID and blah, life in general. But we have a good group of teachers working this fall, and we're looking for another group in the springtime. The challenge is that we are a Department of Ed's funded study, and we have some WWC restrictions, and I just forgot what WWC
What Works Clearinghouse.
Yeah.
It's the stupid name for this idiotic thing that you have to do when you have US Department of Ed money, but they fund us very generously to do really cool materials, so we'll do their little stuff.
We're working with it. It just means there's some timeline restraints that we know don't always filter down to actual schools and classrooms to be able to work with us. But I put it here for your general knowledge. All of this is on our website as well, which I put the links in over here. We welcome you to share with your friends and colleagues in social networks. We welcome you to join us. I think I can also say with Jody here that if the timeline for the actual official INFACT study doesn't work for you, we are working with a handful of teachers sort of in a more informal study, still doing pre and post, but working on your own timeline. A little
and
less
just talking to us about what works and what does, so that we can continually improve the materials.
We're interested in feedback. We're interested in knowing what you think about the materials, what the students think about the materials, and those pre and posts tell us if those materials are working to increase their computational thinking skills.
Questions, thoughts, comments?
Can you remind me the age ranges again, or the grade levels you're looking at?
Grades 3 through 8. We use these, we've chosen those grades in particular because it's a sweet spot where CT is starting to get introduced. I mean, that's moving younger and younger, but where that is, and where the games and robotics and where these different types of activities are entering in a lot of classrooms. So. And we wanted to get early enough that we could build the foundational knowledge and then, or help build the foundational knowledge and span late enough that there were good applications.
So are you seeing this as a curriculum or kind of a platform for more experiential just types of activities?
I keep on slipping into the word curriculum, and we have explicitly chosen not to do that because while this maps very well to CSTA standards, especially in the algorithm and
The algorithm, yeah,
the AD and something else. Yes, yep. that we and that the assessments will map very well to individual tasks in there. We're not covering all the CSTA curriculum. There's a lot of stuff we don't do, and the standards and outcomes. So there's a lot of stuff we don't do, and I don't know that we will. So that would lead me away from using the word curriculum. So we use the word teaching and learning materials.
So, but I guess what I'm trying to figure out is, are you seeing this as kind of more of a exploration by a teacher with the students, or are you seeing it as kind of a set of lessons that they would go through somewhat as if they would do like a module / course or something like that?
We give the flexibility for either one of those to be true.
Okay.
I would say the sequences are set up so you could start on page 1 and go all the way through to the end and have an extremely coherent curriculum, and it will all hang together, and particularly because we're working with neurodiverse learners, all the notation and how we introduce a variable and the color and font we use and all that kind of stuff is just consistent all the way through everything. Those are the strengths that we tried to work on. Whether it introduces every topic you might want to introduce as a CT teacher, that's where I would say we're not as strong. Does that make sense?
Last question. if you were to go from A to Z there, how
Mhm.
many hours would that?
Ooh, a
Just
lot.
curious. Okay.
A lot. I think we're estimating if you really wanted to dig in, it could be 5 to 10 hours easily in each sequence.
Okay,
But we also arranged it so you could probably do a sequence in 2 to 3 hours if you
Okay.
wanted. So and you can do some, and you know, what we really tried to do was when you asked is it exploratory, I would use the term guided discovery. If that from it, you know, we wanted to structure it enough so that we didn't lose you and put a teacher out there to be, you know, floundering around trying to figure it out. But we also didn't want to constrain anybody. So we have we have recommended sequences, and then you can, you know, choose the default and publish and go. Or
Okay.
you can throw in alternatives if you want.
Have
Does
you,
that make more sense?
so I guess one of my other questions, and you don't have anyone from the Department of Elementary and Secondary Education there, has this been considered for use in a curriculum guide, or would you actually put it in for something like a curriculum guide for schools?
So
And Melissa, you might even be able to answer that more so.
I mean, I can tell you, we did not review this for the
Right.
curriculum guide for
Okay.
DESE. Not much I can tell you. And I've also done part of these lessons just because of doing the Zoom beanies last year
Right.
when I pilot it remotely.
I mean, is that something you would want to do in the future, such that, you know, I'm not sure it's totally ready right yet because you're still in testing, but is
So
that
that's
kind
exactly-
of the intent?
Yeah, so
Okay.
we're at the very early stages as we're just doing the efficacy study now. We have just started year 3 of what will likely be a 4-year grant.
Okay.
But what we are trying to do is spend the next year or 2 preparing so that this is ready for scale up.
Okay.
And so part of what we're doing is building an audience along with the research. And so, yes, exactly to your question. The other
Okay.
thing I just want to say is that our team had a research practice partnership with Braintree Public Schools. And we developed a lot of our offline materials, and a lot of our ideas came from that research with those elementary and middle school teachers. And so as of 2 or 3 years ago, oh boy, I'm not going to remember, DCEE, there was some acronym that was the Massachusetts
EDC?
sort of, pardon me?
Was it
No,
E-
you're talking about DESE, the Department
Yes.
of Elementary and Secondary Education? Yeah.
Well, there were some emerging standards, tech standards that kind
Oh,
of
there's
overlap.
DLCS.
Yes, that's it. And those standards inspired our original work that then inspired this. So
Yep, okay.
I haven't gone back to loop them and map them directly, but a
Yeah.
lot of that thinking is there.
Okay. As I said, just,
Yeah. And in 2 years to be prepared, we will have to do that for each state. We will have
Yep.
to go through and figure that out. So any partnerships that can help us get there, we're all ears.
So I had a couple questions.
Yeah.
Are you looking for a regular classroom or more of like a learning center classroom, or either?
Either, but we've been told by our sort of expert teachers that where our power is inclusive in the general ed environment, because we allow that differentiation. It's not that we won't work in a learning room, but we are uniquely strong in a general ed inclusive. So a high neurodiverse population of learners in a general ed classroom is
the research requirements on paper state classrooms with 20% at least neurodiverse learners, which can cover a wide range. Like, we're not asking for 20% of students on IEPs, but might be designated by parents or teachers as having diverse needs.
What we do to define our research audience, our research sample, is that those puzzles that we talked about in the beginning, that the pre-post, there's a set of CT puzzles, and there's also a set of executive function puzzles. They're actually from like NIH toolkit, basically, and they're measuring attention and working memory and cognitive flexibility in a very game-like environment. So what we do is we say, our kids that are scoring low on that attention thing, are they doing as well as their peers on the CT learning? Or if they scored low in the working memory, is our work and the scaffolds, are they helping those students as much as they're helping the other students? That's what our research is looking at. Does that make sense?
Yep. And one other question from me anyways, if people participate in this, do you or people on your team actively work with those teachers in classrooms? Do you join in, or is it just like, here's the curriculum, have at it? Like, what does that look like?
Yeah, so for the WWC study, unfortunately, it has to be what you just sort of said, which is, here it is, have at it. Somebody will call them, and if there's like a technical issue or they can't get in, obviously we support them, but we can't buddy them for like PD as we would like to, because that's not part of the intervention. Having said that, Melissa, I hope you can agree with this. Teachers that becomes our partners, like, they never stop hearing from us. And we're always around to, so once the study's over, if we like to present opportunities, we're actually right now even considering some teachers who might want to, co-design materials with us for a consulting fee. Like, we like to partner with teachers, and we like to help foster that collaboration. The WWC study right now for the time period ties our hands on that. Does that make sense?
I will say,